Initial permutation. As we have noticed, the initial permutation or IP happens only once, and it happens before the first round. It suggests how the transposition in IP should proceed as shown in the figure. For example, it says that the IP replaces the first bit of the original plaintext block with the 58th bit of the original plaintext, the second bit with the 50th bit of the original plaintext block, and so on. This is nothing but jugglery of bit positions of the original plaintext block. The same rule applies to all the other bit positions. As we have noted, after IP is done, the resulting 64 bits permuted text block is divided into two half blocks. Each half block consists of 32 bits, and each of the 16 rounds in turn consists of the broad level steps outlined in the figure. The step 1 is the key transformation. We have noted initial 64-bit key is transformed into a 56-bit key by discarding every 8-bit of the initial key. Thus, for each, a 56-bit key is available. From this 56-bit key, a different 48-bit subkey is generated during each round using a process called key transformation. For this, the 56 bit key is divided into two halves, each of 28 bits. These halves are circularly shifted left by 1 or 2 positions, depending on the round. For example, if the round members 1, 2, 9, or 16, the shift is done by only position. For other rounds, the circular shift is done by 2 positions. After an appropriate shift, 48 of the 56 bits are selected. For selecting 48 of the 56 bits, the table is shown in the figure given below. For instance, after the shift bits number 14 moves on the first position, bit number 17 moves on the second position, and so on. If we observe the table carefully, we will realize that it contains only 48-bit positions. Bit number 18 is discarded. Like 7 others, to reduce a 56-bit key to a 48-bit key, since the key transformation processes involves permutation as well as a selection of 48-bit subset of the original 56-bit key, it is called compression permutation. Because of this compression permutation technique, a different subset of key bits is used in each round that makes DES not easy to crack. Step 2. Expansion permutation. Recall that after initial permutation, we had two 32-bit plain text areas called left plain text or LPT and right plain text or RPT. During the expansion permutation, the RPT expanded from 32 bits to 48 bits. Bits are permuted as well, hence called expansion permutation. This happened as the 32-bit RPT is divided into 8 blocks, with each block consisting of 4 bits. Then each 4-bit block of the previous step is then expanded to a corresponding 6-bit block. Example, per 4-bit block, 2 more bits are added. This process results in expansion is as well as a permutation of the input bit while creating output. The key transformation process compresses the 56-bit key to 48 bits. Then the expansion permutation process expands the 32-bit RPT to bits. 48 bits. Now the 48-bit key is XOR with 48-bit RPT, and the resulting output is given to the next step.